So over here we go to see the factors affecting resistance of a conductor. So every conductor has got a resistance. We learned Ohm's law, V equal to IR. Now we'll see what are the factors that affect the resistance of a conductor. The first factor is the length of the conductor. Now the length of the conductor, it is seen that if the wire is short, the resistance is less. However, if your wire is long, the resistance is more. So this is a short wire, and because it is a short wire, it will have less resistance. And this is a long wire, and because its length is large, is longer, it will have more resistance. So we learn one factor, that the length of the resistance depends on the length of the conductor L. The second is the area of cross section. So the area of cross section A. What do you mean by area of cross section? Is the thickness of the wire. Like in this case here, this would be like a thin wire, while here we could say this is a thicker wire. Area of cross section is more here. Here area of cross section is less. Now less is the area of cross section, more is the resistance. So here this wire has got a smaller A, the cross section is less, so the resistance will be, there will be more resistance. This wire is a thicker wire, so here the resistance will be less. So that is inversely proportional. And there are other factors also. Third is the temperature. Temperature of the wire, T, more is the temperature, more is the resistance. And then we have the last is the nature of the material of which the wire is made of. For example, if it is made of, if the material is like silver, less resistance. If it is made up of iron, more resistance. Okay, so we have four factors: length of the conductor L, area of cross section, temperature, and nature of the material. So let us put it down mathematically. So the resistance, when it comes to length, what have we seen? More is the length, more is the long wire, more resistance. Short wire, less resistance. So resistance is directly proportional to length. Now when it comes to area of cross section, what have we seen? Less is the area of cross section, more is the resistance. So when it comes to area of cross section, we can say resistance is inversely proportional to area of cross section. See, more area, less resistance. It goes in opposite direction, so inversely proportional. We don't take temperature and nature for now. If we put both these together, both these equations, so we get resistance proportional to L over A. So we have resistance proportional to L over A. And like last time we did, if this proportional sign, now I change it to an equal sign, I need to put a constant here. So L over A. L is the length, A is the area of cross section. Now here this constant has got a special name. It is called rho or resistivity. So this is called rho. It's a Greek letter, and the name of that, we pronounce it as rho. It is called resistivity. The name of it is resistivity, L by A. So we have a new formula now. Resistance equal to rho, length over area of cross section. We'll analyze this a little more in the next slide. So we need to remember this one. So we have the resistance formula as rho L over A. Now what would happen if the length became 1 meter? Your area of cross section 1 meter square. Remember, this is area, so the unit is unit square, meter square, centimeter square. Okay, So what would happen if length is 1 meter and area of cross section is 1 meter square? What would happen to the rho, to the resistance? So we have rho, length is 1 meter here, so we put this 1. Area of cross section also is 1, so we put 1. We are substituting in this formula. So in this case now we see this is length is 1, area of cross section is 1, so your R becomes rho. So in this case your resistance now becomes equal to resistivity. Your R becomes equal to rho. When did R become equal to rho? If you take length 1 meter and area of cross section 1 meter square. Let us draw this. So I have a wire here of length 1 meter. So here you see I've taken length as 1 meter and area of cross section 1 meter square. That means this is the area of cross section. This I take as 1 meter square. Then what happens? When I put in the formula R equal to rho L over A, this I take 1 meter, this I've taken 1 meter square, and R becomes equal to rho. So now my R equal to rho here. So how do we define resistivity? Resistivity will be the resistance of a wire having length 1 meter and area of cross section 1 meter square. Repeat. Resistivity is the resistance of a wire having length 1 meter and area of cross section 1 meter square. In the next, let us go to the unit. Now for the unit of resistivity, you just put the formula and find rho, and once you find rho, put all the units and